Here is exercise. One end of a string of length L is connected to a particle of mass m and other to a small peg on a smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle directed towards the center is this. Okay. There is a table and here is a string and here is the stone moving like this. When it moves like this, then the force, the net force on the particle directed towards center. There is a force acting on this towards center. How much is this force? So, when we call force, we know that this is centripetal force. For centripetal force, it comes to our mind that it is equal to mv square upon r. We also know that there will be certain tension in the string. That tension is T. Okay. We also know that there is a centrifugal force which is acting in outward direction. Centrifugal. That balances this force. So, net force becomes 0. So, we have very variety of answers here. What will happen? What is the relation between tension and mv square upon r? Are both to be added or to be subtracted? If there is a balance, then net force is 0, or simply it is tension. Okay. So, for considering the answer of this, if a particle is moving in a circle, then there was a need of centripetal force. It was moving straight, there was a need of centripetal force which pulls it to move in a circle, that force. Who is applying that force here? Very clearly, it is the string which is applying this force. And how much is the force in the string? Answer, here it is given to us that yes, tension is the force which is developed in the string. So, here the force tension. So, tension acts as centripetal force because of which it is moving. Then what is mv square upon r? Answer is mv square upon r is the calculation how much centripetal force is required. So, if velocity is v, the radius is r, then quantity of or magnitude of centripetal force required is mv square upon r. This is the quantity we need, but we are not giving it. Velocity is not giving it, mass is not giving it, radius is not giving it. This is only quantity. Like you go to somebody and say, I want a material which has value of 100 rupees. Then he will give you 100 rupees. With that 100 rupees you will buy it. But what does this show? This shows the value of centripetal force which is required. But who is giving this force? Answer, the tension developed in the string is giving this force. So, how much tension is required? The tension required is mv square upon r. And this will act as centripetal force. T will act as centripetal force. So, there is no question of adding the two. There is no question of subtracting the two. This is value of this force. This is not force. This is only calculation of force. This is force. Tension is a force. mv square upon r is not a force. It is only calculation of the force. And that much force, who gives us? Tension. So, again, what is the force given? This is no. This is not there because centrifugal force is a pseudo force. Only fictitious force, it is not a real force. The proof is, if we cut it, then this body will not go in this direction, this will go here straight. So that is only a fictitious force for calculation, thinking that if there is a force acting inward direction, why it does not go to inward direction? Because we say due to its inertia, there is a force acting on it, we imagine it to be centrifugal force. Okay, so that is reactionary force. Therefore, this is also not there. So we have only this option, that force is the only one real force, that is tension. There is no other real force here. mv square upon r is a calculation that how much tension you want. It is for that. So this is the right option on it. Thank you.